This means that we cannot directly see objects or events that occurred long ago in the past beyond a specific cosmic horizon. The diameter of the observable universe is estimated to be approximately 93 billion light-year, which is significantly larger than the estimated age of the universe, which is believed to be about 13.8 billion years. This apparent discrepancy is due to the fact that the expansion of the universe has caused objects that were once much closer together to move away from each other rapidly, and light from those objects has taken more time to reach us. Therefore, even though the universe is 13.8 billion years old, the space itself has been expanding the distances between celestial bodies. The overall observable universe is a vast and fascinating expanse. But there is still so much that we don't know about it. With each discovery, we gain a deeper appreciation for the complexities of our cosmos. However, through the use of powerful telescopes such as NASA's James Webb Space Telescope and other cutting-edge scientific instruments, we continue to expand our understanding of the structure, composition, and history of the universe. These tools also help us study various cosmic phenomena, from the life cycles of stars to the evolution of galaxies. Join us as we dive into one of NASA's most significant revelations, the contact that the James Webb Space Telescope has just made in the far reaches of the observable universe. If you're interested in keeping up to date with the latest news and discoveries from the cosmos and its myriad surroundings, be sure to subscribe to our channel. Don't forget to like this video and turn on the notification bell so you never miss an update on humanity's journey to understand the universe. Now, what lies beyond the observable universe? This question invites us to explore the boundaries of scientific knowledge and to speculate about realms we cannot yet reach. To access the farthest reaches of the observable universe, humanity would need to develop revolutionary transportation methods that could transcend the very fabric of space-time itself, such as theoretical distortion engines or traversable wormholes. These concepts have long been the subject of vigorous debate among scientists, some of whom believe such feats are simply impossible or fundamentally contradict the laws of physics, particularly the cosmic speed limit set by the speed of light. The feasibility of both faster-than-light travel and the use of advanced technologies that lie beyond our current understanding of physics is a subject of intense debate and interest within the scientific community. Even if such capabilities were theoretically possible, they would require a level of technological advancement and machinery that is far beyond our current capabilities. One of the most mind-bending theories that relates to this is the theory of cosmic inflation. This theory posits that the total size of the universe is at least 10 to the power of 23 times larger than the observable universe. This number is so staggeringly vast that it becomes incomprehensible to the human mind. And since we cannot directly see or measure the unobservable parts of the universe, we have no way of knowing with absolute certainty what lies beyond its limits. Yet this lack of direct evidence does not mean we cannot develop compelling and scientifically grounded theories based on the vast amount of information we have already gathered from distant galaxies and cosmic background radiation. This is where NASA plays a pivotal role. NASA, in collaboration with other space agencies and research institutions around the world, has made numerous groundbreaking contributions to our understanding of the universe. Even before the James Webb Space Telescope became fully operational, NASA had already released awe-inspiring images of the universe, such as the ultra-deep field images obtained with the Hubble Space Telescope. However, when the James Webb Telescope made its debut, it immediately began observing the most distant galaxy ever recorded. These early images revealed the presence of countless galaxies shining in the distant reaches of the cosmos. Galaxies that appear as they were millions of years after the Big Bang, which occurred approximately 13.8 billion years ago. The expansion of the cosmos causes the stretching of light to longer, redder wavelengths, a phenomenon known as red shift. This red shift allows the James Webb Space Telescope to detect infrared light, thereby giving us the ability to peer deeper into the early universe than ever before. As a result, we have been able to observe galaxies forming during the very earliest stages of the universe's history. The James Webb Space Telescope has conducted observations of multiple deep space fields filled with distant galaxies. These studies allow scientists to examine the rate at which stars formed in the early universe and to better understand how the earliest galaxies evolved. The resulting data revealed the existence of a significant population of galaxies that were actively forming stars at rates previously unobserved. These discoveries are both fascinating and thought-provoking. For a long time, humanity has looked up at the night sky and contemplated the possibility that we are not alone in this vast and seemingly infinite universe. With the new determinations from within the observable universe, many scientists and philosophers are now beginning to believe that there must be millions, if not billions, of galaxies in the unobservable regions of the cosmos. This idea is not just shocking but also stirs a deep sense of awe and wonder about the mysteries and vastness of the universe. Are there extraterrestrial beings somewhere out there waiting to be discovered? The likelihood of life beyond Earth has never seemed more plausible. This growing probability leads us to earnestly consider the potential existence of extraterrestrial civilizations or microbial life forms in parts of the cosmos we have yet to explore. There are now thousands of known planets outside our solar system referred to as exoplanets. These have been discovered using various techniques such as the transit method, where a planet passes in front of its host star dimming its light, and the radial velocity method, which detects wobbles in the star's motion caused by the gravitational tug of an orbiting planet. Some of these exoplanets possess characteristics that are remarkably similar to Earth, making them potential candidates for harboring life. This theory is further supported by a groundbreaking discovery made with the help of a James Webb Space Telescope involving an exoplanet named WSP-96b. This planet lies outside our solar system, and an analysis of its light spectrum has revealed something truly surprising: the presence of water molecules in its atmosphere. In addition to water, the spectrum also indicates the presence of haze and clouds, features that were previously thought to be unlikely or even impossible on a potentially habitable planet. Based on habitable environments found elsewhere in our own solar system and considering the accelerating advances in the search for exoplanets, it becomes increasingly difficult to rule out the possibility that alien beings may exist beyond our tiny blue planet. Although we do not yet possess definitive conclusive proof of extraterrestrial life, the discoveries and accumulating evidence continue to suggest that its existence is a fascinating and increasingly probable possibility. Now, what about the concept of the multiverse in relation to the vastness of the observable universe? Let me tell you, the possibilities are as endless as the universe itself. The concept of the multiverse, also known as the many worlds interpretation, is a theoretical idea discussed in both physics and philosophy. It suggests the existence of multiple parallel universes or dimensions that extend far beyond our own. This mind-expanding idea is often discussed within the context of quantum physics, the branch of science that deals with the behavior of particles on the atomic and subatomic scale. According to some interpretations of quantum mechanics, the act of observation causes a quantum system to collapse into a single definite state. However, in the many worlds interpretation, the act of observation instead causes the system to split into multiple coexisting states, each representing a different outcome or reality. It is important to note, however, that the idea of the multiverse remains highly speculative and is not yet supported by conclusive or direct scientific evidence. As such, it is difficult to state with certainty whether the multiverse is a valid concept.